Assalamualaikum and hi everyone, I am Madam Fika. So in this video, we are going to discuss 6 questions that related to chapter 13 under topic gas laws and kinetic theory. Alright, so all the questions is actually from facts questions, which is physics extra questions yang awak semua ada. Okay, so apa tunggu lagi? Jom kita mula dengan soalan yang pertama. Alright, now let's read the question first. Okay, so the pressure of an ideal gas of volume 300 liter at 40 degrees Celsius is given 1.25 times 10 power of 5 Pascal. Alright, so the questions asks us to find the number of moles and the number of molecules of the gas. Okay, so jom kita mula dulu. Okay, so let's take out all the informations given. So we have P is equal to 1.25 times 10 power of 5 Pascal. And then we have volume is equal to 300 liter. Okay, so untuk volume ini kita ada trick sikit di sini. So di mana kita perlu tukar 300 liter to meter cube. So volume would be equal to 300 times 10 power of negative 3 meter cube. Okay, and then we have the temperature. So make sure the temperature 40 degrees Celsius plus 273.15. Alright, so the temperature is in Kelvin and it is equal to 313.15 Kelvin. Alright, so now I'm using equation PV is equal to nRT. So we will use this equation. Alright, and we want to find the number of moles, which is N. Okay, so N is equal to PV over RT. So now we can substitute all the values where P is equal to 1.25 exponent 5, where V is 300 times 10 power of negative 3 over, and then we have R 8.31, and then the temperature is in Kelvin. Okay, and then the final answer, the number of moles is equal to 14.41 moles. Alright, so this is the answer. Okay, and then we want to calculate the number of molecules. Okay, so since N is equal to the number of molecules over the number of Avogadro, so we can use this equation in order to find capital N, iaitu number of molecules. Alright, so let's continue. Therefore, N is equal to the number of moles times the Avogadro number. Okay, so we can substitute 14.41 and then times 6.023 times 10 power of 23. And the final answer, okay, the number of molecules should be equal to 8.68 times 10 power of 24 molecules. Okay, so this is the answer. Alright, so finish example number 1. Okay, so let's proceed to the second questions. Alright, question number 2. So let's read the question first. So we have a gas of mass 0.3 kg is contained in a 0.5 meter cube container and the pressure is given. Determine the root mean square VRMS, okay, of the gas molecule. So A, so let's write the information given. Alright, so we have the mass, which is 0.3 kg, and then we have the volume, which is 0.5 meter cube, and then we have pressure 1.4 exponent 5 Pascal. Alright, so now we want to determine VRMS. Okay, so we want to determine VRMS. So based on this information, okay, we need to choose, okay, the suitable equation in order to solve this problem. Okay, so please remember here we have mass and volume. Okay, obviously we can find density. Okay, kenapa saya kata saya nak kira density? Sebab saya ada pressure and saya ada M over V which is density, dan kita nak cari VRMS. Okay, so bila kita check dekat list of equations, okay, kita tahu salah satu equation yang relatekan pressure, density and VRMS adalah P is equal to 1 over 3 rho VRMS squared. Okay, so saya percaya awak pernah jumpa equation ni. Okay, but now we need to find first what is the density. Okay, so where density is equal to mass over volume. So in this case, we can just substitute 0.3 over where V is equal to 0.5 and density is equal to 0.6 kg per meter cube. Okay, sekarang kita dah ada density, so now we can find VRMS. Okay, therefore VRMS, okay, so here we have VRMS squared. So we want to find VRMS, so it's actually equal to 3P over density, and then don't forget to take the square root. Okay, so kita masukkan semua. Let's substitute all the values. So pressure kita dah ada 1.4 times 10 power of 5, and then we have density 0.6. Alright. Okay, so kita kira-kira, kita akan dapat, okay, therefore VRMS is equal to 836.7 meter per second. Okay, so this is the answer for part A. Alright, and then let's proceed to the second part, which is part B. So here we have a vessel of volume 45 liters, contains 3.0 moles of gas at 35 degrees Celsius. Alright, so we want to find, okay, the gas pressure. Okay, so here we have volume, we have the number of moles, and we have temperature. This is very easy. We can use the ideal gas equation, PV equal to nRT. Okay, so in this case, I will take out all the values. Okay, for B, we have volume in liter, 45 liter, but make sure you change to meter cube. Okay. Alright, so the number of moles is given 3.0, okay, moles. And then we have the temperature, which is 35 plus 273.15 Kelvin. Oh, sorry, plus 273.15, and it's equal to 308.15 Kelvin. Okay, so now I will use equation PV is equal to nRT. Okay, we will use this equation. So we can try to solve the first question. We want to find the pressure. Okay, so P is equal to, nRT over V. Okay, so kita masukkanlah N3, R adalah 8.31, T is 308.15. Okay, over V is 45 times 10 power of negative 3. Therefore, pressure kita akan dapat 1.71 times 10 power of 5 Pascal. Okay, so this is the answer for B1. Okay, and then B2, soalan tanya apa tu? Okay, look at here. When the pressure of an ideal gas is increased, okay, kita baca betul-betul. So kita ada P1, pressure is increased, okay, from 5.5 exponent 4 Pascal to, this is P2, ataupun P initial, and then we have P final. Okay, terpulanglah, nak guna P1 boleh, P2 boleh. Okay, kalau kata nak guna P1 dengan P2 pun tak ada masalah. So this is P1 and this is P2. So its volume decrease. So here we have two values for volume. Okay, where this is V1 and this is V2. Okay, so given that if the initial root mean square, Okay, VRMS initial is equal to V. So we want to find what is the final VRMS. Okay, so kita keluarkan dulu semua maklumat. Let's try. So B2, okay, kita buat kat sini. Macam tak muat kan? So saya akan padam ni. Boleh ya? Saya akan padam yang ini. Okay, sekejap kita padam dulu. Okay, kita padam. Okay, so now let's try to solve B2. Okay, kita kecilkan sikit kita punya tulisan. Okay, 15. Alright, so for B2 we have P1. We write P1 is equal to 5.5 exponent 4 Pascal. And then we have P2, okay, 1.5 times 10 power of 5 Pascal. And then the volume, we have V1, where the volume is decreased, okay, to 0.5 exponent negative 3 meter cube. Okay, and then VRMS, okay, VRMS 1 is equal to V. Okay, and then we want to find VRMS 2. Okay, so kita nak carilah VRMS 2. Okay, so based on these informations, I will use equation PV is equal to 1 over 3. So let's write first. PV is equal to 1 over 3 NM VRMS squared. Okay, so formula ini diberi di hadapan list of equations di dalam kertas soalan. Okay, so you can just use this equation. Alright, so kita nak cari VRMS 2. Okay, so it's a bit tricky here, but we can try to rearrange this equation first. Okay, so saya akan cuba rearrange this equation. So we are going to have equation, okay, initially. So I will write initial. Okay, so VRMS 1 squared is equal to, okay, 3P1 V1 over N1 M1. Okay, and then for the final part, okay, ataupun saya tulis kat bawah ni lah. Sekejap So for the final part, so VRMS 2, ini yang kita nak cari nanti, squared 3P2V2 over N2 M2. So I have equation number 1 and equation number 2. Okay, so kita akan buat di tepi ni. Okay, sorry lah tak muat. Okay, so now let's write equation number 1 divide equation number 2. Okay, so let's try. So 3P1V1, okay, so VRMS 1 squared, dia akan jadi macam ni lah. Okay, boleh lah sini, VRMS 1 squared over VRMS 2 squared equal to, so kita masukkanlah 3P1V1 over N1 M1, okay, bahagi 3P2V2, so dia akan jadi darab. Okay, N2 M2, dia akan jadi terbalikkan lah. Okay, saya percaya ini semua boleh tahulah. Okay, so yang kita boleh cancel, kita cancel out. So we have 3 here, okay, and then N dengan M constant. Okay, so VRMS, okay, here we have VRMS squared. Okay, so VRMS 1, soalan dah bagi tadi, VRMS 1 is equal to V. Okay, so we can just write V squared is equal to, over VRMS 2 squared. Okay, jangan lupa kita ada squared kat sini. Equal to P1 V1 over P2 V2. Okay, So daripada sini we can try to rearrange the equation. So kita nak cari VRMS2, where VRMS2 is equal to square root. Okay, square root sekejap, P2, okay, P2V2, okay, P2V2 times V squared, okay, times V squared over P1V1. Okay, so semua nilai ni dah ada. So jawapan kita akan tinggalkan in terms of V. Okay, so sekarang kita dah ada P2, kita dah ada V2, V ini kita tinggalkanlah V squared. Okay, so this one is VRMS1 equal to V. So yang tak ada nilai tu kita tak payah substitute. Sekejap saya padam balik. Okay, so kita ada P2, V2, P1 and V1. Okay, kita masukkanlah semua nilai yang kita dah ada tadi. Alright, so when we substitute, okay, so saya perlu padam ni soalan yang tadi tu. Tak muat saya padam, sorry. Okay, so dia akan jadi VRMS2 is equal to square root. So P2 kita berapa? P2 kita tadi 1.5, right? 1.5 exponent 5 V2 0.5 exponent negative 3 V tadi adalah VRMS1 is equal to V. So kita biarkan over P1, okay, 5.5 exponent, okay, 5.5 exponent 4, and then V1 is equal to 2.5 times 10 exponent negative 3. Therefore, VRMS2, you akan dapat in terms of V equal to 0.739 volt. Sorry, bukan volt, V. Okay, dia nak in terms of V tadi kan. Okay, so this is the answer. Okay, so finish question number 2. Okay, now let's proceed to question number 3. Okay, so question number 3, the RMS speed of the atoms of a monoatomic gas at a temperature 20 degrees Celsius. Okay, so for A, I will take out all the informations. Okay, so saya ada VRMS is given. Okay, 603 meter per second, and then it's given the temperature in degrees Celsius. So make sure you calculate in Kelvin. Okay, and then we want to find the mass of mass of an atom of the gas. Okay, so I will use equation VRMS equal to square root, okay, 3 kT over m. Sebab kita nak cari apa ni tadi? Kita nak cari, sekejap saya kecilkan sikit ni. Okay, sebab saya nak cari ini m. Okay, so we want to find m, mass of an atom of the gas. Okay, formula ini juga diberi, jangan risau kat depan ada. So 603 is equal to square root 3k kita adalah 1.38 exponent negative 23 and t is 293.15. Okay, over m. Alright, so daripada sini we can calculate, therefore m is equal to 3.34 times 10 power of negative 26 kg. Okay, so this is the answer. Alright, and then let's proceed to question B. Okay, kita tulis kat sini lah. Okay, what is the root mean square speed of oxygen molecules at 300 K given that the molar mass? So this time we are given the molar mass of the oxygen, okay, and the molar mass is given in gram per mole. Okay, molar mass adalah capital M. Make sure you tukar kepada kilogram per mole, okay? Alright, okay, so temperature is given 300 Kelvin. So Okay, this time I will use equation VRMS. Kita ada dua equation VRMS. Yang pertama tadi, kita ada ini. VRMS square root 3KT over mass, okay, small m. So this time we will use VRMS square root 3RT over capital M. Okay, so this is another equation. Boleh? Okay. So, sama juga, we just substitute all the values. So, kita nak cari VRMS. Oh, sorry. Sekejap ya. So, VRMS is equal to square root 8.31. T is 300 over molar mass 0.032. And then, therefore, VRMS is equal to 483.4 meter per second. Okay, so this is the answer for question 3, and then finish question 3. Alright, so we can proceed to question number 4. Okay, so let's proceed question number 4. So let's read the question first. So calculate the temperature of carbon dioxide given the molecular mass is 44 gram produced in a fire if the root mean square velocity of the gas is given, right? Okay, so now I want to answer question A. So given that the molar mass, okay, in gram, so make sure you change to kilogram. Okay, so 0.044. Okay, and then 0.044 kg per mole for the molar mass, and then we have VRMS 472 meter per second. So now we want to calculate the temperature T. Okay, so macam sebelum ni kita akan guna formula VRMS is equal to square root 3RT, sebab kita ada molar mass. Kalau kita guna 3KT over small m, which is mass of the gas. Okay, so I will use this equation. Alright, so we can just so now we can just substitute. Okay, kita nak cari temperature T. So rearrange the equation, kita akan dapat T is equal to VRMS squared. Okay, pastikan rearrange dengan betul Okay, so masukkan nilai dia. T is equal to VRMS kita dah ada. Okay, so capital M and 8.31. Okay, therefore the temperature you akan dapat 393.3 okay, Kelvin. Okay, cuba kira 393.3 Kelvin. Okay, make sure in Kelvin lah. Okay, make sure in Kelvin. So, saya akan check semula. 472 squared times 0.044 divide 3 times 8.31. Okay, 393.2 393.2. Alright, okay. Finish part A. And then for part B, okay. So given that here we have the volume, and then we have the number of moles, and then the temperature. And if helium behave like ideal gas, calculate the total translational kinetic energy of the molecule of the gas. So kita nak kira, okay, tengok betul-betul kat sini. This one is total, total translational kinetic energy. So when we talk about total translational kinetic energy, okay, total, okay, so the formula is equal to 3/2 nRT. Okay, jangan tersilap nRT. Okay, so we can just substitute where 3/2 n is given 2.5, R is 8.31, and the temperature must be in Kelvin. So 10 plus 273.15. Okay, so you tekan kalkulator elok-elok, you akan dapat 8.82 times 10 power of 3 joule. Okay, so this is the answer. And then this is B1 and then B2. So for B2, we want to calculate the average. Kalau tadi total translational kinetic energy, this time the average molecular kinetic energy. So formula for K, okay, average translational kinetic energy, okay, KE is equal to 3/2 KT. Okay, so this is the formula in order to calculate average kinetic energy. Boleh? Okay, so we can just substitute. Okay, K is 1.38 exponent negative 32. Okay, and then the temperature. Temperature tadi dia bagi berapa? 283 kan? Kita kira tadi 10 plus 273.15. So, tambahlah 10 plus 273.15. Okay, so you akan dapat 5.86 times 10 power of negative 21 joule. Okay, so this is the answer. So, finish question 4. So, let's proceed to question number 5. Okay. Alright, so now let's read the question. A balloon of diameter 20 centimeter. Okay, so 20 centimeter. So saya akan tulis dekat sini. Diameter dia adalah 0.2 meter. So the radius should be 0.1 meter. Okay, and then the temperature, the balloon is filled with the helium gas. Okay, 30 degrees Celsius. Okay, which is equal to 303.15 Kelvin, and the pressure is in ATM unit. Make sure you change to Pascal, which is 1 ATM bersamaan dengan 101.3 exponent 3 Pascal. Okay, so number 1, how many atoms? So kita nak kira the number of atoms. Okay, so the number of atoms ni dia adalah N, capital N. Okay, the number of atoms. Ini yang kita nak kira. Okay. Okay, so kita nak kira the number of atoms in the balloon. Okay. So, we can use equation. Equation apa kita nak pakai? Kita ada P. Okay. Daripada D, kita boleh kira volume. Kita ada diameter. Okay. PV and RT. Kalau saya tulis PV equal to nRT. Okay. So, daripada sini, sebenarnya kita boleh cari, kita P kita dah ada. V kita boleh kira lah. Where volume for the balloon. Okay. Volume dia adalah 4/3 pi R cube. Boleh kira lah. Okay. Kita boleh kira volume dia. Masuklah R kita dah ada 0.1 meter. So, bila kita substitute, kita akan dapat 4.19 exponent negative 3 meter cube. Boleh? Okay. So, N, R kita ada, temperature pun kita ada. So, daripada sini, sebenarnya kita boleh cari N. Okay. Jadi, daripada N ni nanti, kita tahu relationship antara the number of moles dengan the number of molecules. Okay, N over NA. Okay, so kita boleh gunalah formula ni untuk cari this one. Okay, so kita cari dulu the number of moles, N is equal to PV over RT. Okay, so substitute all the values dulu. P kita dah ada 101.3 exponent 3. V pun kita dah ada. Volume dia tadi 4.19 exponent negative 3. Okay. 8.31 and then the temperature 303.15 Kelvin. So the number of moles you akan dapat 0.168 moles. Okay. So kita akan kira dekat sini. Therefore N is equal to the number of moles times the Avogadro number. Okay? So Avogadro number berapa? 6.02 times 10 power of 23. Therefore, okay, N, okay, is equal to 1.01 exponent 23 heliums atoms. Okay, so this is the answer for 5, question number 5, 1. And then calculate the average kinetic energy. Okay, average kinetic energy tadi kita dah tahu formula dia adalah okay, K translational average kinetic energy KT. Okay, so saya rasa awak tak ada masalah lah. Okay, sekejap. Okay, kita boleh guna formula ni. And then temperature kita dah ada tadi. So times K 1.38 exponent negative 23 times 303. Okay, 303.15. Okay, kita dah kira tadi. Okay, so kita tekan calculator 1.38 exponent 23 times 303.15 times 3 divide to 3 over 2. So the answer is 6.27. 6.27, okay, ataupun 6.28. Sebab 275 ni saya dapat. Okay, 275. 6.28 exponent negative 21 joule. Okay, so this is the answer. Alright, so finish question number 5. So I think we stop here. Alright, so finish for part 1. So for part 2 akan disambung oleh Sir Zul. Okay, jangan lupa untuk tengok part 2 untuk buat lebih banyak soalan untuk chapter 13. Okay, so that's all from me. Thank you. Okay, jangan lupa anda juga boleh singgah ke channel YouTube saya iaitu Madam Fika Fiki. Okay, so Assalamualaikum dan selamat sejahtera. Jumpa lagi. Bye-bye.